Okay, by way of review, don't write this down, this probably should be reviewed. When we did function notation, we would say something like y is equal to 3x plus 7. And we said, well, we're going to give it a name. We're going to call it f of x is equal to 3x plus 7. And then we would say something like, oh, I wanted to do f of something. 3 times the something plus 7. And we would put a number in, I don't know, -2.
Oh, it'd be 3 times -2.
3 times -2 plus 7. And we would say then, in the end, we would say f of -2 is equal to something. What is f of -2 equal to?
1.
1. And we would say then, all right, so now we remember that this here is the input. And what we do with the function, what we do with the input gives us an output. Remember this? No?
I'll run. Okay.
No?
Yes, no? Oh, that's why I say
Yeah. You remember this. This is review.
Yeah.
Okay. This also means it's an x value and a y value. This is going to be like a -2, and that's going to be a 1, and so forth like that. Input and output, right? Function notation.
Yes.
Does not mean f times x. It means x is the input. Okay, good. Algebra and composition of functions. Now, you do need to write these down. Let's do f of x is equal to x minus 1. And then let's call it another function, g of x is equal to 2x minus 3.
So you just gave us 2.
Give you 2 functions. Okay, write those 2 functions down. They're different. In fact, I'll even say this. I'll even say that the f of x I'll do in blue, x minus 1, and the g of x I'll do in red, 2x minus 3. Okay. Now we're going to be doing basic operations on both of them at the same time. Okay, so number 1, the most basic operation is addition. So I could do something like f of x plus g of x. I can add those 2 functions together. What's that going to be? It's going to be x minus 1 plus 2x minus 3, right? Just adding those 2 things together, right? Easy peasy? Okay. So that would give me then what? 3x minus 4 as my new function? Okay. Now the book's going to write this a little bit differently than I'm going to write it, and you need to be aware of both. When I write it f of x plus g of x, I think that helps you understand best what's going on. The book will write it like this, though. The book will say f plus g, both of which have an input of x.
That's weird.
It is a little weird, but you need to be able to recognize it. This means add the 2 functions together, and the input for both is x.
What's kind of?
It means the same thing.
Oh.
Just add the 2 functions together. Now, for giggle's sake, let's do this. Let's do f of 3 plus g of 3.
Man, I can't write today for some reason.
And maybe you should just watch this. Just watch.
All right.
F of 3, that's going to be 3 minus 1. Agreed? And then g of 3 is going to be 2 times 3 minus 3. You agree with that?
Yeah.
And all I'm going to be really doing is I'm just going to be doing the addition of whatever that output is. Okay, so that's going to be like what? 2 plus 3. I get 5 as my final output. You agree with that?
Yeah.
Okay, now watch. If I come over here to the sum of the function, and I'm going to say 3 times something minus 4. Notice that the input for both of these, f and g, was the same thing, right? It was 3. Same input for both. What's 3 times 3?
9. Oh, it's 5. Okay.
Minus 4. I get 5. They're the same thing. Yeah?
3 minus 1 is equal to 3.
It equals 2.
What are you talking about?
3 minus 1 is equal to 2.
Why is the f equal to 3 like f3?
What?
It's f of 3.
Oh, I thought it had to equal to 3.
No, it's the input. Input of 3 on f. What's f? F is going to be the input minus 1. So it's the input minus 1, which is 2.
Oh, never mind.
You got it now?
Never mind. Yeah, I
Okay.
know we were doing it backwards.
Now, on this left-hand side, I did them individually. I put 3 into F, and I also put 3 into G, and I got results from both of those, and then I added them together. This one over here, when I added them together without putting a number in, I got a new expression, 3x minus 4, which does the exact same thing. Are you tracking with me?
Mm-hmm.
Sometimes you want to just put them together and get just a new third equation that does the same thing automatically. Or you could do it individually in steps. Sometimes
The other one, that one's easy.
well, sometimes you'll need to do one and another one. So let's be aware of both.
I catch up because I'm
Okay, go ahead. Okay. If you can add functions together, what else can you do? You can subtract them. Thank you. So what is f of x minus g of x? That's going to be the group, something, something, minus the other group. Yep, x minus 1 is the first one. The second one is going to be 2x minus 3. Notice my color code in there? Are you tracking the color coding?
Yes, it'd be easier to put the numbers into that one.
It might be, maybe not. Okay, this is going to be x minus 1 minus 2x. Don't forget to distribute that negative in there, plus 3. So my final my third function is going to be negative x plus 2. That's the difference. Order matters, though, when you subtract. F of x minus g of x is not the same thing as g of x minus f of x. Order matters. Yeah, right?
So you just combine it like terms, basically?
Yeah. But I have to do the subtraction, right? We've subtracted polynomials from each other before, so this is not new. Now, this is how the book is going to write it. F minus g, not times, although it looks like it, of x. All of it's got the same input. And again, you can do it in 2 little pieces like I did over there with the addition, or you could use just a single input with the final simplified expression over there, negative x plus 2. I'm not going to spend more time on that one. If you can add them and subtract them, what else do you think you can do? Multiply them, good. So let's do 3. You could do f of x, watch my nomenclature here, f of x times g of x, we'll use a glorified dot. It's a big fat dot. That means multiply. I don't want to use parentheses for multiply because I'm already using parentheses to do my function notation, and I don't want them to mean 2 different things. So I'll use a big fat dot for multiply. Well, that's just going to be something times something else. That's going to be x minus 1 times what? 2x minus 3. Okay, that's not hard. Just multiply. X squared minus 3x minus 2x. This is not even factoring. This is just multiplying. Plus 3. X squared minus 5x plus 3. I fumbled that. Thank you.
So Mark, we're using the stuff from the very first grade.
Maybe. Still got your notes from that?
I do. Wait, that's my other.
Well,
I have
that's my
3.
very first page is like putting stuff in and like having to input.
Evaluating, yeah.
You know, I've gone through 3 notebooks in this class.
Good. Save them.
I like to see.
30 years from now, you'll open those things up and your handwriting will look completely different to what it will be.
I don't think it will because I still don't know cursive.
I think it will. Well, I went back to cursive as an adult. I got stuff from when I was in high
I feel
school.
like they stopped teaching it when I was in
Yeah, they don't know.
elementary school.
One of the things that's important about basic education is you should be able to teach yourself after you're done.
No, I just do an R and then a bunch of squiggles.
You
When
should-
I was
you should-
little, my uncle told me you just connect all the letters.
You can teach yourself cursive.
I was like, yeah, man, I know cursive, and then I just write my name.
Brian, if you wanted to, you can go get yourself some manuscript books and teach yourself how to write again. It's not a big deal.
Well, like in fifth grade, we did the trace over, you know,
Yeah.
but I would have forgot that.
I bought those books because several years ago I was going to teach myself how to write left-handed.
Oh, really?
Yeah.
Did you ever manage to do it?
I made some progress.
I broke my arm when I broke my arm when I was younger.
Wait,
and I
try
learned how
to
to
do the
write
next
left-handed.
section in left-handed.
No, because my job is to communicate. Okay. Right. Now, here's how the book is going to write it. F times G of X means the same thing. Okay, multiply the two functions together. And if you can multiply them, guess what else you can do?
Divide.
You can divide them.
That one,
Okay.
I feel like that's the hardest.
For, you can do F of X divided by G of X, which in this case is going to be the blue one, which is X minus 1, divided by 2X minus 3. But we have to say here that 2X minus 3 can't be something, because it's a denominator. Can't be what? Can't be 0. Good, thank you. Now, the way the book's going to write it is going to be F divided by G, and then it's going to be of X out front. Okay, that's all pretty straightforward. I don't know that there's anything new or even anything difficult about that.
Shouldn't be too bad. So far.
Okay, now we're going to have some fun.
No, we're not.
No, that's boring. Okay. Now, let's have some fun. I will stay with the same functions. I will stay with f of x is equal to x minus 1, and then g of x is equal to 2x minus 3. Okay. Now, are you watching? I've got my
No, that bothers me.
I've got pencil eraser stuff on my screen. Does it still bother you?
Yeah, that one's still bothering me. That one's even.
There we go.
And then why is the bottom so big? It's like a
Oh, Brian, right now, he says judgmental, man. You ask him to change it, he changes it.
My 3's got a fat bottom.
Three's right.
Kids are killing me. All right. Now, don't write this down. Watch.
Oh, wait. Oh, I already started writing.
Just watch. Watch what I do now. Okay. I'm going to do G of 5. What's G of 5?
5.
Well, that's equal to 2 times something minus 3. What's my input?
5.
5. Good. So now G of 5 is equal to what? 7. Now watch. F of something is going to be the something minus 1, right? What am I going to put in for F?
8.
No.
5.
No.
3.
No.
0.
No.
1.
No.
2.
No.
X. 4.
Come on, wake up. You're just guessing blindly.
X.
X minus.
No.
Oh! G5.
Oh.
7.
7.
5. What?
Oh. Oh, yeah.
As far as we get there eventually.
I know.
I don't like this.
I would have got.
You only like it because you don't know how to conquer it yet.
What is
shut up.
what is this equal to? What is this equal to? What is f of 7 equal to? Come on,
2x
7 minus
minus
1?
3.
7
6.
6. Thank you.
That is it.
Okay, now write that down.
Oh,
Just like I have written it vertically.
so 5 equals 6. Brian, shut up.
Okay, here's what's happening. I have an input of 5, right? Didn't I start with 5 as my input?
Yes.
Yes.
You got help with
So
the
5 is my input, and I got 7 as a what? as an output. Then I did what?
Input it.
I used 7 as the input for the next level. Okay. I used 7 as an input for the next level, and I got my final output of 6. Here's what I did. I linked these functions together. I did this. I did f of g of 5 is equal to 6.
Are we gonna have to graph these eventually?
Yes. Okay. This is a composition function, where the output for one becomes the input for the next one. Are you tracking with me here? This is crucial. This step right there. Right here.
Yes.
Put 5 in, I got out 7. I then took the 7 and made that the input for the next one, and then I got a final output of 6.
So
You're
there's
linking these together.
You need to do both equations, right?
Yes, you use both equations. But up here, remember on this one? Remember on this one, f of x plus g of x, I was using 3 as the input for both of them. You follow? This is fundamentally different than what we did previously. Up here, I used 3 as the input for both of these. If I was going to do subtraction, I would use the same input for both of these. That's why it's f minus g, and then x is a single input.
But Mr. Mark, if you just like kept doing that, would it make it graph?
Yeah. We're combining functions now. One function inside another function. Okay, so what I want you to do now is I want you to do this one. Oh, I need to tell you how the book's going to write it.
Can I guess?
There's 2 different ways of writing it. My method is going to be f of g of x. And notice my exaggerated spacing there. The book is going to do f composition, an open dot. Looks like fog, but it's not,
Oh, that looks complicated.
of x. That's why a solid dot means multiply. An open dot, it's not a letter O. An open dot, it's not written on the line, it's in the middle. Okay? An open dot means composition function. It means you're putting one function inside another function. Do you see what I've got going on right here? I've got an outer function called f, and then I've got an inner function.
How does the mind map?
That's my gene.
How's the mind map elaborated? Your way or the other way?
This way.
All of those.
Okay. Let me do it a bit differently. Okay. Now, I'm going to do the same problem, but I'm going to do it in my nomenclature. I'm going to do f of g of, what was the input? 5. F of g of 5. Well, this is going to be f of, what's g of 5? G of 5 was going to be 2 times 5 minus 3. Isn't g 2x minus 3? Yes? Okay. So now, this is going to be f of, what is 2 times 5 minus 3?
2 times 5 minus 3 is 7.
7. Now, what's f of 7?
G.
Well, isn't the f function an input
Yeah.
minus 1?
Oh, right.
What's the input?
6.
7.
Oh.
The input 7. Final answer?
Oh.
6.
Oh, okay.
Notice this 7 is just an in-between link. The 7 doesn't wind up in the final answer. 7 is just an in-between link. Sure you. Takes practice. Now, let me show you the book's way. F composed of G of 7. Here's my little hint. I'm kind of proud of this. You are in the fog. Go backwards.
Like, sure.
Nope. Watch. Take 7 and put it into G.
Oh.
So, wait, so.
Put 7 into G. Go backwards.
Oh!
Take the 7, put it into the G.
Oh, so you mean do the g of x?
So G of 7 is equal to what? 2 times 7 minus 3.
11.
Okay. So, oh, wait a sec. I don't want to use 7. I want to use 5. I want to show you that you get the same answer.
7.
No.
Okay.
G of 5.
What's about
5. 5.
7.
What's G of 5?
7?
7. So now the 7 goes into F.
Yeah.
7 goes into F. So then 7 minus 1, 6. You're going to put G or 5 into G, get that answer. And then whatever that answer is, you're going to put that into F.
Can I write down your little thing?
Sure. When you're in the fog, go backwards. It's not always fog, because it may be G composed of H. When you're in the go, when you're in the ga,
Go backwards.
K of H. When you're in the ko,
Keep it there for us.
okay. I'm going to give you another one to do here in a minute.
When you're in the fog, go back.
That was your. Since you went first off. So you're right.
Those are nightmares. I can't leave you.
What does the O mean again?
It's not an O.
The open.
The open dot.
Yeah, that's gonna confuse
Composition
me. I'm gonna
function.
think it's this far.
Yeah. When you see it printed in the book or online, you'll know that it's not an O.
That's just like F times G.
No, it's not.
That's F inside of G.
Solid dot means, yeah,
Yeah, so F inside of G, or G inside of F.
whichever one goes first.
Them together.
Which is why I like my way of writing it here. When I write it like this, F of G of X, you can see very clearly that G is the inside function and F is the outside function. So G is inside of F. Parks, be quiet. Okay. New situation here. Let's do F of X is equal to 3x squared. And then let's do G of X is equal to 2x minus 1. Okay, find F of G of 3. Or the way the book would write it, F of G of 3.
I never do like low G. I always like
Are you going to put 3 into G or F first?
G.
like.
This one here clearly tells you that you're going to put 3 into the G function first.
Oh, I thought you were asking maybe G.
This one says if you're in the fog, go backwards. You can put 3 into the G function first. Oh, that's a G, not an A. Okay.
Oh, yeah.
Parks, good job, Parks.
Okay. Oh, you got a hand on
That's not my glove.
Good hand on it.
I think, I don't my head now. It's gonna come getting tired.
It's going to help your brain. Connor, what'd you get for your final answer?
I got 4.
Maverick, what'd you get for your answer?
Nope. I don't know.
Jared, what'd you get for yours?
Or what did you get?
Can't tell you, bro, because I got it right. You have to.
Jorge, what'd you
your
get?
own weight, Connor.
I still haven't made progress.
Connor,
Oh, it's 3 this morning.
oh my God, bro.
It's 2 this morning.
No, it's not even close, dude. It's double digits.
Oh.
Connor, what's G of 3?
Is it G of 3?
You had to come over here to the G function and put 3 in.
Oh, I got
Yeah.
Oh, good.
nice.
2 times 3 minus 1?
That's 5.
Okay, so that's 5.
Did you get the? Oh.
Now, what's f of 5?
Yes, look at
Why do you do the up above?
This is now f of 5.
Oh,
G of 3 has now been replaced with 5. What's now f of 5?
there's 9. 5 squared.
It's
and
3
then
times 5 squared.
Oh, it'd be 25 times 3.
Final answer?
75.
75.
Yes, sir.
Okay. Now, if you wanted to use the book's way, you're going to say f 3 into G gives me a what?
5.
Write it underneath. 5. And then 5 into f gives me 75.
70?
Now, does order matter?
Yes.
Yes. Always.
I'm pretty sure.
Well,
Does it?
let's find out.
Well, what was this morning?
This is an exact class.
I said 5.
Let's do G of f of 3. Yep. What is f of 3? It's 3 times 3 squared. So G of 27. What's G of 27? 2 times 27 minus 1?
Would be
54.
53.
53. Okay, are these the same thing?
You said it at.
Are these the same thing?
No.
No.
So order does matter.
Order does matter when you do a composition function here.
Yeah, no, it's.
Okay. Now, I want you to watch something.
So if it's gone, you're solving for G. But if it's on, you're solving for F.
You got to figure out what the inside function is, what the outside function is. Let me do this. Let me do f of g of x without a number. Okay, watch. What's my f structure? Isn't my f structure equal to my outer function? Isn't it going to be 3 times an input squared? Do you agree with that? 3 times an input squared?
For F?
Yes.
Yeah.
Okay. Now, what am I putting inside? I'm putting inside G. What is G?
All right, get in here.
This is 2x minus 1. So a 2x minus 1.
Oh.
Oops. I think that's right. This is f of g of x. So now let me try f of g of 3. 12 times 3 squared minus 12 times 3 plus 3. 9 times 12, what is that? I forget what that is. 108?
108, yeah, 108.
108 minus 36 plus 3.
You said one.
I said 78.
Okay, what do I get?
Oh my god.
I get 75. I want you to watch. I want you to watch. Didn't I do f of g of 3? Yes?
Yeah.
Come on, marker. Right here. Didn't I do that right here? How did I do it previously? I found an output of 5 and then linked them together. But look, this equation right here, when you do them abstractly without a number, you get a single equation that does it all in one step. I don't have to link it and find the 5 and then use the 5 and the f to find the 75. You follow what I'm saying? I don't have to do the 3 into g and then get an output of 5 and then go from the 5 into the f and get an output of 75. This equation right here, when I just simply put a function inside another function. No, it's good. When I put a function inside a function, I get a new function which does the thing simultaneously. So part of what you're going to need to do today on the homework is to put one function inside another function. Okay, let's do a little bit of practice on that. I'll make it easy. Let's do h of x is equal to 2x plus 7, and let's say that k of x is equal to, I don't know, 3x minus 5. So k, or h in blue, k in red. Now, don't write this down yet, just watch. Okay, you're watching, pencils down? Ryan, I'll be the boss of the class. H of k of x. Okay, what's my inside function and my outside function?
Your inside function.
Inside function is k. Outside function is h. Outside function is h? Do you agree that the outside function is h?
Yes.
Okay, good. Set up the outside structure first. What's the outside structure? It's going to be 2
X plus 7.
times an input. Replace an input with parentheses. 2 times an input plus 7. I get that from right here. Okay, what am I putting in?
3x minus 5.
There we
Okay, now I
go.
get it.
I'm putting in a 3x minus 5.
We just do the first way, we work out one and then.
Nope. You've got to be able to get a new function that is the composition, not just linking numbers together. So the new function then, simplified, 6x minus 10 plus 7, 6x minus 3, that's h of k of x. Because if I do 2 times negative 5, that's a negative 10, and then plus 7, that's a negative 3.
Oh, I didn't see the plus 7. Oh. Yeah.
Yep, plus 7.
Oh.
Now, another one would be k of h of x. So what's the k function?
K function.
So it's 3 times an input minus 5. What's going to be my input? The input's going to be 2x plus 7. Basically, I'm replacing h of x with what it is, 2x plus 7. K of 2x plus 7 means I'm going to put 2x plus 7 in every time I see an x in k. So what's this? 6x plus 21 minus 5 plus 16. Okay, notice that they're not the same thing. K of h of x. Yo, dog, we heard you like functions. We put a function in your function. Composite functions are when your input for one function is an entire other function. You put an equation inside another equation. Okay. Now, let's go back to something simple. I see people writing, so maybe I'll wait for them. No, solve it for what? I haven't told you what number to input at all. All I've told you is just combine the functions.
Oh, we need input.
You have to have an input.
Oh,
I haven't told you what number to input for him.
I know.
Yeah. Okay. What if you don't know? What if you just have a table of values? Let's do something like P of X, and don't write this one down yet, just watch. 5 and 7 and 3 and -1, 4, 0, and -2, 9. And then Q of X, I'll make a different function. I'll call this 9 and -6, and then I'll call this 3 and 5, and then I'll call this one 0 and 12, and then I'll call this one -1 and 19. Okay, I want, I want P of Q of 3.
Okay, so.
I don't know what the equation is. All I've got is a table of values. So this one's actually fairly easy. Okay. My input's going to be 3. Where do I start? With the P or the Q? Okay, so go to Q, find an input of 3. The output is 5.
So, 5 in
But now I use 5 as the input. This is now P of 5. 7, yeah. See, Jared?
Whoa, wait.
I told you it was easier.
Jared, you're so smart.
Look, the output for the Q on when it's, Ryan, the output for 3, find that over here as an input. Oh, there's the input.
I get it.
There's your final output. 7.
I get it. Nice. Thank you, Jared.
Okay. What about Q of P?
Q of
3.
3. Alright, so it would be.
And then, so the final output would be 19.
19.
19.
Why is that?
Because
I use P of 3, find P, find an input of 3. Here's an output of -1. Go over here now in Q and find the input of -1. 19. Final answer 19. See, it's linking these things together.
I like this.
Cut it up.
Okay, here's a challenge one for you.
Oh,
I want to do,
just say no.
stop it. I want to do Q, no. I want to do P of Q of 0.
Oh, I see.
For him?
That makes total sense. Fine.
What's the answer?
I'm ready for this test.
What's the answer? No.
Well, we have
What
an
an
answer.
Zero.
I thought we were talking
It's
about
0, Mr. Mars. 0 is 0.
I'm doing this one right here.
My God, Jorge.
Oh,
You
shit.
pay attention or no?
Alright, I don't
No,
know.
I'm paying attention to 0.
No.
You're so stupid. It's 4.
No.
It's
Thank you,
0.
Jared.
Oh,
Jared.
Zero is
Does
always
not
almost
exist.
0.
Now watch.
Oh, I thought, I
The
didn't.
in- The input is 0. Which function?
Q.
Q. So come to Q, find an input of 0. 12.
No, look for 12.
Now I have to do 12 as an input for P. Is there an input on P of 12? No, so it doesn't exist.
Oh my God.
Oh. Where did I get the 4 from? Why did
I don't know.
Because
You said 4?
I was about to
Because
say.
it told 0.
How about
I said
this?
12.
Q of
No. I just went straight to 4.
P of 4.
Twelve.
12, that'll work. That's where you got the 4 from, Marks.
Yeah.
You got the 4 because you're associating this point right here with this point right here.
No, but I didn't even look at those. I was just like, okay, 0 to 12.
P of 4. Find an
I saw
input
it.
on P of 4. Do I have an input of 4 on P? Yes. What's the output? 0. Find the input of 0 over here on Q. 12. Sooner or later, you'll do these with the graphs too.
That seems like it'd be pretty.
Oh, I get it now.
Oh my goodness, good, because my back hurts. I'm gonna sit down.
Graphing with inputs and outputs is easier than like,
Mr. Marsh's been
it's
on,
the
like,
easiest way of graphing.
recently you've been on a roll about finishing just in time. It's 10:09.
Yeah.
Well,
Oh
this
my
is now the third time I've taught this lesson. I've had practice, which ought to tell you something about how you should study for a math test.
You've been teaching this lesson for.
Because Jorge, I want you to get on a roll. I want you to get on a roll of getting an A on a math test. How do you do that practice?
Mr. Marsh, haven't you been teaching for 20 years?
Yeah.